Alright, so now we're going to turn our attention to spheres and finding the surface area and the volume of spheres. There's not a whole lot of fanfare to the formulas for it, and not a whole lot of talking we're going to do about why it is what it is. You're just going to have to memorize them. So some definitions first. A sphere is the set of all points in space that are equidistant from a given point. That given point is called the center, so it's like a circle. It's what a sphere is, right? A three-dimensional circle. It's just a set of all points that are equidistant from a given point. Spheres have a radius, just like a circle does, and it's a segment from the center to a point on the sphere. And it also has a diameter, just like a circle does, and it's just a chord, so the endpoints are on the sphere that goes through the center, so like that. Okay? Surface area. If we want to paint this ball, right, how much paint are we going to need? And the formula looks a lot like the formula for the area of a circle, except we multiply that area by 4. Why by 4? Well, that's the part that we don't need to get into a whole lot. Just need to know that you multiply it by 4 for the surface area. Surface area is in square units. We square the radius. 2 squared is 4, so it's got to be 4 pi r squared. I don't know how you want to remember it, but that might be one way. But that's the formula. And pretty easy to put in place, right? So for this first example, if we want to find the surface area of the sphere, we just use our surface area formula, right? 4 pi r squared, where here the radius is 8. So we go 4 times pi times 64, and we get 256 pi, which we of course could multiply out if we needed to, but I'll leave that for you to do. Okay? Simple enough. So standardized test practice. Go ahead and give this a shot and come up with which of these choices is going to be the diameter of that sphere. And keep in mind you're trying to find the diameter. Take a second, work it out, and you start the video back up and see if you're right. Okay? Did you get this? Since the surface area is 20.25 pi, we set that equal to 4 pi r squared. Divide both sides by 4 pi. We get 5.0625, square root both sides, and the radius is 2.25. But remember that you're trying to find the diameter. So you've got to double the radius, and so our answer there is B. Okay? All right. Some more definitions for you. We've talked about cross sections before. If you were to slide a plane through a sphere, you would create a cross section. If that plane captured, if that cross section included the center, if that plane was slid through the center of the sphere, then we get what's called a great circle. The cross section would just be that two-dimensional circle, and it's called the great circle. The great circle is the biggest circle in the sphere, right? And it's the circle that holds the center of the sphere. And then, of course, half of a sphere is called a, hopefully you know, a hemisphere, right? And so a couple of definitions you need to be aware of there. All right. Another example for you. In a sport called sphering, a person rolls down a hill inside an inflatable ball surrounded by another ball. The diameter of the outer ball is 12 feet. Find the surface area of the outer ball. Take a second, find the surface area, start it back up, and see if you're right. And did you get 144 pi square feet? Remember that they gave us the diameter of the ball. And we had divide the diameter by 2 to get the radius and plug that into the surface area formula. So the surface area of the outer ball is 144 pi square feet. Okay? Easy enough. Now, volume. Volume, of course, we're moving away from how much paint would you need to cover the outside of the sphere to, if you're going to fill it with water, how much water would you need? And again, without a whole lot of developing the formula, here it is. And so the volume is 4/3 pi r squared. Compare that to the surface area formula, which is 4 pi, well, this is 4/3 pi r cubed. I think I said squared. The surface area is 4 pi r squared. And you can compare these, right? Instead of squaring the radius, we're going to cube it. That's because volume is in cubic units. And how to remember the 4/3, right? I don't know. Since volume's in cubic units, we're going to divide the 4 by 3 as well. I don't know. However it makes sense for you to remember, but it's 4/3 pi r cubed, not squared. All right? So, to find the volume, we've got a soccer ball whose diameter is 9. Find that volume. Well, if the diameter is 9, that means the radius is half of that, or 4.5. The volume formula is 4/3 pi r cubed. So 4/3 times pi times 4.5 cubed. Okay. Now, we want to multiply that out. So we go 4.5 cubed. And then to multiply that out, we're going to multiply by 4 and then divide by 3. And the volume ends up being 121.5 pi. At which point you could always multiply the pi out round to the nearest tenth. You may have to do that at some point. And so when you do that, the volume becomes approximately 381.7 cubic inches. Okay? But we're just plugging in and using the formula. Just got to know the formula. Okay? Last but not least, there are composites, a very popular way to find the volume or even the surface area of anything. Is you may be able to break it down into parts and consider, you know, which of the parts we need to fill with volume and which we need to, you know, scoop out or subtract out, that kind of thing. For example, in this composite, we've got a cylinder that has been scooped out. And so this picture would be better off if it looked something like this. So I'm going to scoop out this hemisphere. So something like this. Although I think I scooped too much out. You actually would still see this. So it looks something like that. Okay. Anyway, if you can imagine this cylinder and then taking an ice cream scoop and scooping some of that hemisphere out, if we wanted to find the volume, how much water would it take to fill a shape like that? Well, maybe not that we scooped it out, but that we placed a hemisphere upside down in it so that you couldn't fill that space with water. I think that's the point. Well, we would have to find the volume of the cylinder, which is just the area of the base times the height, and subtract out the volume of that hemisphere, which is 4/3 pi r cubed, but then divide all of that by 2. Cut that in half. So what would that look like? Well, area of the base of a cylinder is a circle, so we just need pi r squared h minus 4/3. The radius of that hemisphere is 2. And then divide all that by 2 to get the hemisphere. So now it's just a matter of simplifying. So pi times 2 squared times 2 is going to be the volume of that cylinder minus, well, 2 cubed is 8. 8 times 4 is 32. 32 divided by 3 is just 32 over 3 times pi. And we're supposed to be dividing all that by 2. So we get 2 squared is 4 times 2 is 8. So 8 pi minus, dividing by 2 is the same thing as multiplying by a half. So if we multiply by a half, we can simplify here, cross simplify. 1 in this 32 becomes 16. And so we go 16 over 3 pi. And then we can subtract that out. What is this? 24 over 3. Subtract that out, we get 8/3 pi. And then you can multiply the pi out if you needed to. But this is going to be 8/3 pi inches cubed. Okay? So some fraction work there, but easy enough, hopefully, as far as the concept goes. Okay? Homework's out in Canvas. Go ahead and give it a shot. Have it ready for next time.